presence of cabling and air ducts can create a fire hazard, as the ducts can act as a conduit for the spread of smoke and flames. It is important to note that not all types of cabling pose the same level of risk. The enumerated CMP cable is specifically designed for use in air ducts and other plenum spaces. This type of cable has a special flame retardant coating that helps to prevent it from igniting and spreading flames. While plenum rated cable is not completely fireproof, it does provide a much higher level of protection than standard cabling. In addition to the type of cable used, the way in which the cable is installed can also affect the fire hazard. For example, if the cable is bundled too tightly or if it is not properly secured, it could create a potential ignition source. It is recommended that the installing contractors refer to the National Fire Protection Association 17 National Electrical Code, also known as NEC. This code provides requirements for the installation of electrical wiring and equipment, including cabling and air ducts. Specifically, attention should be directed to the following sections of the NEC. Firstly, Article 300 wiring methods, and secondly, Article 725 Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits. These sections provide detailed requirements for the installation of cabling and air ducts, including the type of cable that must be used, the method of installation, and the maximum number of cables that can be installed in a duct. It is also recommended that a fire safety inspection be conducted of the buildings where the cabling is installed. This inspection should include a review of the type of cable that is being used, the way in which the cable is installed, and the overall fire safety of the building. By following these steps, you can help to ensure that the cabling in the air ducts is installed in a safe and code-compliant manner. Article 300 covers wiring methods in general. Several sections within Article 300 are pertinent to installations in air handling spaces. These sections address issues such as the types of wiring methods permitted, support requirements, and the need to prevent the spread of fire or products of combustion. Article 300.21 addresses spread of fire or products of combustion. Electrical installations must be performed in a manner that minimizes the spread of fire and products of combustion. Openings around electrical penetrations through fire-resistant rated walls, floors, and ceilings must be fire-stopped using approved methods to maintain the fire resistance rating. This requirement prevents fire from spreading through the building via electrical pathways. Article 300.4 covers protection against physical damage. Wiring methods must be protected from physical damage. This is particularly important in air handling spaces where the wiring may be exposed to mechanical damage from maintenance activities or other equipment. The specific type of protection required will depend on the wiring method used and the environment in which it is installed. Article 300.11 covers securing and supporting. Wiring methods must be securely fastened and supported. Cables must be secured in place to prevent them from sagging or coming into contact with other equipment. The supports must be designed to withstand the weight of the cables and any potential mechanical stresses. Article 725 provides requirements for Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits. These circuits are commonly used for low voltage control and signaling applications in buildings. Several sections within Article 725 are relevant to installations in air handling spaces, including restrictions on the types of cables permitted and requirements for cable installation. Article 725.3 covers classifications. Class 1, Class 2, and Class 3 circuits are classified based on their voltage and power limitations. These classifications determine the types of wiring methods and overcurrent protection required for the circuits. Class 2 and Class 3 circuits are generally considered to be safer than Class 1 circuits due to their lower voltage and power levels. Article 725.135 covers wiring methods and materials on supply side. Wiring methods and materials on the supply side of the power source for Class 2 and Class 3 circuits must comply with the requirements of Chapters 1 through 4 of the NEC. This section ensures that the power source is properly protected and that the wiring methods used are suitable for the voltage and current levels involved. Article 725.136 covers wiring methods and materials on load side. Wiring methods and materials on the load side of the power source for Class 2 and Class 3 circuits must comply with the requirements of Article 725. This section specifies the types of cables that are permitted for use with Class 2 and Class 3 circuits, as well as the installation requirements for these cables. Plenum-rated cables are often required for Class 2 and Class 3 circuits installed in air handling spaces. Article 725.139 covers separation from other conductors. Class 2 and Class 3 circuit conductors must be separated from power conductors and other non-power limited circuit conductors. This separation prevents the possibility of electrical interference or accidental contact between the different types of circuits. The NEC provides specific requirements for the minimum separation distances between conductors. Beyond those specific articles, the National Electrical Code contains several articles that are directly applicable to the installation of communications cabling in air handling spaces, often referred to as plenums. These requirements are primarily focused on fire safety, aiming to limit the spread of fire and smoke through these spaces. Article 800 of the NEC covers communication circuits. This article addresses the requirements for installing communication cables, including those used for data, telephone, and other communication systems. Article 800.24 covers mechanical execution of work. Communication circuits must be installed in a neat and workmanlike manner. Cables must be properly supported and secured to prevent damage or strain on the conductors. This section emphasizes the importance of good workmanship in ensuring the long-term reliability and safety of the installation. Article 800.50 covers general. This section provides general requirements for communication circuits, including grounding and bonding requirements. Communication circuits must be properly grounded and bonded to minimize the risk of electrical shock and to protect equipment from damage due to voltage surges. Article 800.113 covers cable marking. Communications cables must be marked to identify their type and voltage rating. This marking helps to ensure that the correct type of cable is used for the application and that the cable is properly installed. The markings must be legible and durable so that they can be easily identified even after the cable has been installed. Article 800.154 covers applications of listed communications wires and cables. This section specifies the types of communication cables that are permitted for use in different applications. Cables are listed and classified based on their fire resistance and other characteristics. The appropriate type of cable must be selected based on the specific application and the environment in which it will be installed. For example, plenum-rated cables are required for use in air handling spaces. Article 800.179 covers support of conductors. Communication cables must be supported by the building structure in such a manner that the cables will not be damaged by normal building use. Attachment methods shall not cause damage to the building structure. This section emphasizes the importance of properly supporting communication cables to prevent damage and ensure their long-term reliability. Cables must be supported in a way that does not damage the building structure. Article 800.406 covers abandoned cables. The accessible portions of abandoned communications cable shall be removed. This section requires the removal of abandoned cables to prevent them from becoming a fire hazard. Abandoned cables can accumulate dust and debris, which can increase the risk of fire. Removing these cables helps to improve the overall safety of the building. Article 800.550 covers cable substitutions. The use of substitute cables shall be permitted. Where the substitute cable is installed in locations requiring the fire resistance characteristics of the original cable, the substitute cable shall meet those fire resistance requirements. This section allows for the substitution of cables as long as the substitute cable meets the fire resistance requirements of the original cable. This provides flexibility in selecting cables while ensuring that fire safety is not compromised. Article 725 of the NEC covers Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits. These circuits are commonly used for low voltage control and signaling applications in buildings. The requirements for these circuits are designed to minimize the risk of electrical shock and fire. Class 1 circuits are the most powerful and require the most stringent wiring methods. Class 2 and Class 3 circuits are less powerful and have less stringent wiring requirements. Article 725.3 covers classifications. This section classifies Class 1, Class 2, and Class 3 circuits based on their voltage and power limitations. The classification determines the types of wiring methods and overcurrent protection required for the circuits. Article 725.25 covers overcurrent protection. Class 1 circuit conductors must be protected against overcurrent. Overcurrent protection devices, such as fuses and circuit breakers, must be selected and installed in accordance with the requirements of the NEC. The overcurrent protection device must be sized to protect the conductors from overheating and potential fire. Article 725.27 covers wiring methods on supply side. Class 1 circuit conductors must be installed in accordance with the wiring methods specified in Chapter 3 of the NEC. This chapter provides requirements for various wiring methods, such as conduit, cable, and raceway. The wiring method selected must be suitable for the environment in which it will be installed and must provide adequate protection for the conductors. Article 725.52 covers wiring methods and materials on load side. Class 2 and Class 3 circuit conductors must be installed in accordance with the wiring methods specified in Article 725. This article provides specific requirements for the types of cables that are permitted for use with Class 2 and Class 3 circuits, as well as the installation requirements for these cables. Article 725.135 covers wiring methods and materials on supply side. Wiring methods and materials on the supply side of the power source for Class 2 and Class 3 circuits must comply with the requirements of Chapters 1 through 4 of the NEC. This ensures that the power source is properly protected and that the wiring methods used are suitable for the voltage and current levels involved. Article 725.136 covers wiring methods and materials on load side. Wiring methods and materials on the load side of the power source for Class 2 and Class 3 circuits must comply with the requirements of Article 725. This section specifies the types of cables that are permitted for use with Class 2 and Class 3 circuits, as well as the installation requirements for these cables. Plenum-rated cables are often required for Class 2 and Class 3 circuits installed in air handling spaces. Article 725.139 covers separation from other conductors. Class 2 and Class 3 circuit conductors must be separated from power conductors and other non-power limited circuit conductors. This separation prevents the possibility of electrical interference or accidental contact between the different types of circuits. The NEC provides specific requirements for the minimum separation distances between conductors. Article 300.22 covers wiring in ducts not used for air handling, wiring in ducts used for air handling plenums, and other space used for environmental air plenums. This section provides specific requirements for wiring installed in ducts and plenums used for environmental air. The requirements are designed to minimize the risk of fire and the spread of smoke in these spaces. Wiring installed in ducts not used for air handling must be installed in accordance with the requirements of Chapter 3 of the NEC. Wiring installed in ducts used for air handling plenums must be plenum-rated cable or enclosed in a metal raceway. Other spaces used for environmental air plenums must also use plenum-rated cable or be enclosed in a metal raceway. The NEC defines a plenum as a compartment or chamber to which one or more air ducts are connected and that forms part of the air distribution system. Plenums are often located above suspended ceilings or below raised floors. Plenum-rated cables are specifically designed to have low smoke and flame characteristics. These cables are tested and listed in accordance with UL 910, the standard for safety for test method for fire and smoke characteristics of electrical and optical fiber cables used in air handling spaces. Cables installed in plenums must be marked as plenum rated, such as CMP for communications plenum cable or FBLP for fire alarm plenum cable. The NEC provides specific requirements for the installation of cables in plenums, including support requirements and restrictions on the use of cable ties and other accessories. Cables must be supported in a manner that prevents them from sagging or coming into contact with other equipment. Cable ties and other accessories used in plenums must also be plenum rated. The NEC also addresses the removal of abandoned cables in plenums. Abandoned cables can accumulate dust and debris, which can increase the risk of fire. The NEC requires the removal of accessible portions of abandoned cables in plenums. Article 310.15 covers ampacity of conductors. This section provides requirements for determining the ampacity of conductors. The ampacity of a conductor is the maximum current that the conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The ampacity of a conductor is affected by factors such as the size of the conductor, the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. The NEC provides tables that list the ampacities of conductors based on these factors. Conductors must be selected and installed so that their ampacity is sufficient for the load they will carry. Overcurrent protection devices must be sized to protect conductors from overheating and potential fire. Article 310.16 provides ampacity tables for conductors insulated with various materials such as THHN, THWN, and XHHW. These tables list the ampacities of conductors based on their size and temperature rating. Article 310.15b2 covers adjustment factors for ambient temperature. The ampacity of a conductor must be adjusted for ambient temperatures above 30 degrees Celsius or 86 degrees Fahrenheit. Adjustment factors are provided in tables in the NEC. Article 310.15b3 covers adjustment factors for the number of conductors in a raceway or cable. The ampacity of a conductor must be adjusted if there are more than 3 current-carrying conductors in a raceway or cable. Adjustment factors are provided in tables in the NEC. The NEC also addresses the installation of conductors in underground installations, including direct burial and underground raceways. Conductors installed in underground installations must be protected from physical damage and moisture. Direct burial conductors must be listed for direct burial and must be installed at the proper depth. Underground raceways must be installed in accordance with the requirements of the NEC. Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handle enclosures. This article provides requirements for the installation of boxes and enclosures used to terminate or splice conductors. Boxes and enclosures must be properly sized and installed to provide adequate space for conductors and splices. Boxes and enclosures must be securely mounted and supported. Article 314.3 covers uses permitted. This section specifies the types of boxes and enclosures that are permitted for use in different applications. The type of box or enclosure selected must be suitable for the environment in which it will be installed. Article 314.16 covers number of conductors in outlet, device, and junction boxes and conduit bodies. This section provides requirements for determining the number of conductors permitted in a box or conduit body. The number of conductors permitted in a box or conduit body is based on the size of the box or conduit body and the size of the conductors. The NEC provides tables that list the maximum number of conductors permitted in different sizes of boxes and conduit bodies. Article 314.17 covers conductors entering boxes, conduit bodies, or fittings. This section provides requirements for protecting conductors as they enter boxes, conduit bodies, or fittings. Conductors must be protected from abrasion and physical damage. The NEC specifies the types of fittings that are permitted for use to protect conductors as they enter boxes, conduit bodies, or fittings. Article 314.27 covers outlet boxes. This section provides specific requirements for outlet boxes. Outlet boxes are used to terminate wiring devices, such as receptacles and switches. Outlet boxes must be securely mounted and supported. Outlet boxes must be properly sized to accommodate the wiring devices and conductors. Article 314.28 covers pull and junction boxes. This section provides specific requirements for pull and junction boxes. Pull and junction boxes are used to provide access to conductors for pulling or splicing. Pull and junction boxes must be sized to accommodate the conductors and splices. Pull and junction boxes must be accessible.